Good morning. My name is Andrew Gonzalez, and this is Lab 1 Charge Tapes for Physics 2212. So, the introduction. The purpose of this lab was to observe the interaction between a charged piece of tape and several other objects with varying charges. For example, our hand, which has a neutral charge, or another piece of tape that is also positively charged. Studying these interactions will help to determine the amount of excess charge on the charged piece of tape. So some of the materials you need for this lab are a roll of clear tape, a ruler to measure it, a flat surface to charge the tape, and two objects for support for the final part of the lab. A computational model was also created using CloseGrip to replicate the charges of the tape and how it interacts with the objects around it. So before we go into the experiment, we have to review some fundamental principles. The first one is Coulomb's law, which is the electric force between two charges. That's what it describes. And that can be given by K times the absolute value of the charge of both objects multiplied, divided by the distance squared. And K is the Coulomb constant, which is also known as 1 over 4 pi epsilon 0. Gravitational force is also prevalent in this lab. It describes the attractive force between two objects with mass. It doesn't matter how big or small the objects are. This could be tape versus tape, tape versus your hand, or just the gravitational force we're all used to, tape versus Earth. Newton's second law is also used in this experiment. It's given by F equals ma, and this principle describes how the force applied on an object and its mass affects its acceleration. So to set up the experiment, the U-tape was first created by sticking it to the base tape on a flat surface and ripping it off, which ends up charging the U-tape. And this charged U-tape was put under a neutral tape that was hanging between two neutral objects. And the length of the tape B, which is the tape being hung, was 20 centimeters. What the first observation we noticed was that when tape A, the charged tape, would enter within around 2.5 centimeters from tape B would start to move. So some assumptions and errors that we should go over. Air resistance is considered negligible for this. Also, the long tape is calculated as a single point charge, which the long tape is the neutral tape. And we also assume each piece of tape has an equal amount of charge evenly distributed throughout the tape. And also each atom occupies an area of 1 times 10 to the negative 20 meters. Some errors that could have happened were that each piece of tape had a loss of charge due to poor handling. So this could have been once we ripped off the U-tape. And also in reality, charges basically never equally distributed throughout the tape. So the results. Our group determined that the magnitude of the gravitational force was 1.96 times 10 to the negative 3 newtons because we calculated the weight of the tape as 0.2 grams and we multiplied that by gravitational force. We used gravitational force to find that the electric charge on tape B was 1.36 times 10 to the negative 13 coulombs. And finally, combining these two answers that we got, we found that the number of electrons lost was 8.5 times 10 to the fifth, or 850,000 electrons. Considering the dimensions of tape B and the approximate length of an atom, we calculated that the total amount of atoms on the sticky side of the tape was 3 times 10 to the 17. This is my CloseGrip. As you can see on the picture on the right, the top green charge is the uncharged tape, which has the red arrow pointing down for gravity and the yellow arrow pointing up as the electric field. So some things to discuss. The first question was if electrons are positive and protons were negative, what would happen? And they would end up staying the same because of the physical laws. So like let's say we had two positive charges, they would separate from each other, but if we turn both of them negative, they'd still end up separating. Like the charge U tape, if instead of being charged positively, it was negatively charged, it would still push away the neutral charge tape put between the two objects. So we also have to discuss some losses and errors. Handling handling the charged tapes after we ripped it off the base tape. Some charge gets on your hands or other objects, like for example the tape, and this will reduce the tape's charge and effectiveness. Also, moisture and salts on your hands can act as conductors, which cause electrons to dissipate and weaken the charge. Minimizing contact with other objects besides the base tape ensures the tape retains its charge, leading to clearer, more reliable observations.